Hello and welcome to this brief video, which will walk you through the process of establishing a learning environment for those looking to work with the Kubernetes, Nirmata, and Kyverno products. My name is Bob Brenson, Solutions Architect at Nirmata. Now, to begin, let me be clear in pointing out that the information being sourced for this video comes directly from the documentation sites of both Kubernetes.io as well as Kyverno.io. So one might ask, why the need for this video then? Well, the fact is, as detailed as the documentation is on both the aforementioned sites, in some cases the detail is far beyond what one might need just to establish a learning foundation. And frankly, in some cases can be confusing. While in other cases, some minor details just might be missing. So what I'm looking to achieve is to walk you through how to take an operating system, in this particular case I'll be using CentOS, and walking you through step by step on what you'll need to do to get a successful learning environment up and running. So as you can see on the screen, I have a fully installed copy of CentOS. Now, there are a couple minor modifications that need to be made to the OS configuration, so I might as well get that out of the way right from the beginning. Essentially, I'll need to disable SE Linux, and I need to disable swap. So I'm going to begin by disabling SE Linux at the shell by typing set_enforce --0. This disables the feature immediately. Now, to make this a persistent setting, one would have to edit the file etc selinux config and set the value for the variable SE Linux to disable, which you can see I've already done. Next, I'm going to disable swap at the shell by typing swap_off --A. This will immediately disable memory space from being paged out to the swap partition. Because this is a real-time command, this will need to be followed up by editing the etcfs tab file and commenting out the swap reference. Again, through the cat output, you can see I've already taken care of this. Okay, so now that I've got all of that out of the way, I need to install a container engine. So to begin, the first thing I'm going to do is su. For the purposes of my demo, I'm going to choose Docker. I'm going to add the Docker repository to my system. So in my case, the command to add the repo on CentOS will be dnf config-manager --add-repo equals https://download.docker.com/linux/CentOS/docker-ce.repo. I'll display the simple text in case you need to record it. Do bear in mind this information can be found on the Docker documentation page for this and other operating systems. So next I'm going to actually install the Docker CE packages. Because in my case I already have some alternative conflicting packages, I'm going to include the option Allow Erasing. As I receive messages requiring confirmation, I'll accept by simply typing Y and then the return key. Now, while this is going through the installation motions, let me put on the screen the applicable command I just typed, dnf install docker-ce-allow erasing. Once the Docker installation is completed, we need to start the Docker service by typing systemctl start docker. And to set the service to start automatically, I'm going to type in the command systemctl enable docker. Now I'm going to return to my regular user account by exiting su. The next step is to add your non-privileged user to the Docker group. You would do this by typing sudo usermod -a Docker and in all caps $user, followed by root's password. From here, I'm going to go ahead and restart the system. After I've logged back in, I'm going to visit the Kubernetes documentation site. It's there that I'll navigate to the Getting Started link. Select Learning Environment, and I'll install the kubectl tools. So I'll simply select the appropriate link for my operating system, which again in this case is CentOS. So for that, I'll select Package Management as my option and Red Hat Distribution. From here, I'm going to go ahead and copy the text provided and paste it into my terminal. I should clarify I need to SU to complete this operation. Just for information's sake, you can see there's quite a bit of other information on this page that doesn't have any direct bearing on what we're looking to accomplish here. But what I will do is execute the command kubectl version -- client to confirm that kubectl is actually working. So I'm going to return to the previous screen in order to install Minikube. Minikube will allow us to run a single node Kubernetes cluster on our system. So I'll scroll down and select the button for the Minikube startup guide. I'll then select the appropriate options for my setup, which in this case, again, is Linux for the OS, x86-64 for the architecture, and in my case, I'm going to go ahead with binary download. I'm going to simply copy the text string provided into my terminal shell. Once completed, I'll initiate Minikube by simply typing Minikube start. From here, it'll go through its installation and configuration process, or as I like to say, it's voodoo magic, until it returns back to the shell prompt. As opposed to simply having you stare at the screen, let's go ahead and skip ahead. To confirm that we're good to go, let's check to see if I can retrieve pod information by typing the command minikube kubectl get po-A and verify that it returns data, which, as you can see, it does. I can also bring up the Minikube dashboard simply by typing minikube dashboard. So now we have a system that's prepared to be a learning environment for either Kubernetes in general or, in our specific case, Kyverno. Thank you for taking the time for watching this brief video.